Okay, on 6.5 we are going to graph rational functions. But before we do that, we need to write down the steps. And the first three, those are just review questions, so those are gone. Okay, so first you want to figure out what the domain is, or the points of discontinuity. So I'm going to cross this off actually. The points of discontinuity is where you look at the denominator and you set it equal to 0. That's where you're going to have a break in the graph. And actually the first thing that you want to do is factor. And this is the second thing you want to do. Okay, the third thing you want to do, based upon the points of discontinuity, is to figure out if you have a vertical asymptote or a hole in the graph. A vertical asymptote is where you're going to have an equation. A hole in the graph is where you're going to have an ordered pair. Okay, horizontal asymptote is where you divide your leading terms. Okay, we talked about all that on 6.4. Okay, now we got some new stuff. To find the x-intercept, that's where you set your numerator equal to 0. The y-intercept is where you substitute x, or 0 in for x. And in this step, if needed, you just make a table. Sometimes you'll have to make a table, sometimes you won't. So those are all the steps in order to graph rational functions. So we will be referring to that as we move along here. Okay, there are 6 graphs. Let's see which one I want to do first. I'm going to cross off number 2. I'm going to do number 4 first, actually. So what I probably should do is maybe draw in my XY axis. Okay. The first step is I want to factor, which it's already factored, so I'm good there. Then I'm going to find any points of discontinuity. So I'm going to set my denominator equal to 0. So if I do that, my points of discontinuity will occur at 0 and positive 6. Okay, after I do that, I'm going to cancel, and that's actually not one of my steps on here. So before I determine this, I want to cancel first. Well, these cancel. That means the 0 canceled out. Since the 0 canceled out, that's going to be a hole in the graph. Whichever didn't cancel out, that is a vertical asymptote. Okay, now I got to figure out what the y value is. So I'm going to write down what's left after I cancel. Nothing's on top, so I'm going to put a 1 there. And then x minus 6 is in the denominator. So I'm going to put 0 into my simplified equation. And that's going to give me negative 1/6. Okay, I'm going to be using this now to answer the rest of the questions. My next step is to find any horizontal asymptotes. So to do that, I'm going to divide my leading terms. Since I have more x's on the bottom than I do on the top, my denominator is bigger. That means my horizontal asymptote occurs at 0. Okay, so now I'm going to find any x-intercepts and y-intercepts if possible. To find the x-intercept, I set my numerator equal to 0. Well, if I do that, I get 1 equals 0, which is not a true statement, so I do not have any x-intercepts. To get the y-intercept, I'm going to substitute 0 in for x, and I'm going to get negative 1/6, which happens to also be the hole in the graph. Okay, now I'm ready to put all this together. So I am going to graph, first of all, the vertical asymptote. So I'm going to go over to 6 on the x-axis. I'm going to draw in a vertical asymptote. Okay, now I'm going to graph the hole at 0, -6. So here's my origin. I'm going to go down a little bit and put a hole there. I actually just put a hole there. Horizontal asymptote is going to occur at 0. So right here I have a horizontal asymptote. I don't have any x-intercepts, and then my y-intercept is where the hole is. Okay, so my two asymptotes broke up my graph into 4 regions. I have one here. I look at the dotted line. So based upon these dotted lines, I have 4 regions. I have top right, top left, and bottom right. Since I have a point in the bottom left, that's where one part of my graph is going to be. I just follow the asymptotes. Okay, now, since I have something in the bottom left, I'm going to have something in the top right, and all you have to do is sketch it. So if you have one vertical asymptote, you are going to end up with a butterfly. We should probably write that down somewhere, maybe up here. So if you have one vertical asymptote, your overall graph is going to be a butterfly. If you have 2 vertical asymptotes, then you have 2 scenarios. And we'll get to that in a second. If you have 0 vertical asymptotes, then your graph is going to be a line. Okay, so we'll refer back to that as we do another one. Okay, let's see. The next one I would like to do is actually number 5. Okay, so let me draw in my XY axis. I'll use this color this time. All right, and I'm not gonna do number 3 since I kind of written that space. Okay, so the first thing I wanna do is factor. So this is gonna factor to x plus 3, x minus 3. After I factor, I'm going to find any points of discontinuity. That's where I set my denominator, both parts equal to 0, and then I solve. So the first one's going to be -3, the second one's going to be +3. After I find that, I'm going to see if I have any vertical asymptotes or any holes in the graph. That's where I look to see if something cancels. Well, I don't have any x plus 3 or x minus 3s on the top. Nothing cancels. Since nothing cancels, I do not have any holes in the graph, which means I have 2 vertical asymptotes. I'm going to have one at -3 and one at +3. All right, now I'm going to find a horizontal asymptote. Okay, to do that, I'm going to divide my leading terms. So since nothing cancels, I can just go back to my original problem. So if I take x divided by x squared, it's going to be easier to do it in the non-factored version. My denominator has a higher degree. Since it has a higher degree in the denominator, horizontal asymptote occurs at y equals 0. Okay, numerator, that's where you set your x-intercept. X-intercept is where you set your numerator equal to 0. So if I set x equal to 0, then I get 0. Okay, the y-intercept is where I put 0 in for all the x's. So if I want to go back to the unfactored one, I can put 0 right there and there. I'm going to get 0 on top, -9 on bottom, 0 divided by -9 is 0. So the y-intercept is also 0. Okay, let's see what we have so far. So I have 2 vertical asymptotes. I'm going to have one at -3 and +3. And then I have a horizontal asymptote at 0. And then x-intercept and y-intercept is at 0. Well, that's all the information that I have. So I'm going to have to make a table. So this time it gives me, if I look at all the dotted lines here, I have 1, 2, 3, 4, 5, 6 sections. So first I have to figure out what the middle is going to be. The middle is either going to be a snake or a parabola. But in order to figure that out, I have to make a table because that's all that's what I have to do. I only have 1 point. So I'm going to pick a number that's in between these 2 dotted lines. I'm going to pick 1 and -1. Those will be easy to work with. And again, since nothing canceled out, I'm going to refer back to my original problem. So I'm going to put 1 in for both of these x's. So that's going to give me 1 on top. That's going to be 1 squared, which is 1 minus 9 is -8. So 1 -1/8 is one of my answers. I'm going to put -1 in. So I get -1 on top. -1 squared is +1, minus 9 is -8. That turns out to be +1/8. So -1 up a little bit. Well, just by looking at the way the points are, the middle is going to be a snake, but it's going to be a backward snake. If the middle is a snake, then that means the outsides are going to be a butterfly. If the middle is a parabola, the outsides are going to be a volcano. Okay, so make sure you have this written down. Now, since I don't have any points, it's okay. I need to have something here and here. I don't want to have it here and here because it's too close. This is too close to this. I want the one that's farther away because I need it to kind of be symmetrical. So I'm going to have something there and there. It's just a sketch, really. So overall, that's what my graph looks like. Now, these definitely take practice. I don't expect you to get these right away. Okay. Let's turn the page. So I am going to cross off number 7, but I'm going to do 6 and 8. First, let me draw in my XY axis. Okay, so the first thing I want to do is I want to factor. This time I can factor the numerator as well as the denominator. Okay, so now that I have it factored, I'm going to write down what the points of discontinuity are. If I look at the denominator, I'm going to have a -2 and a +2. Okay, nothing cancels. Therefore, I don't have any holes in the graph, but I do have 2 vertical asymptotes. I'm going to go ahead and draw those in now. Okay, now I'm going to find the horizontal asymptote. That might be easier to go back to the unfactored problem because all I have to do is divide leading terms. And since they have the same exponent, I just divide the coefficients. So that's going to give me just y equals 1. I'm going to go ahead and graph that. I'm going to go up to 1 and draw in a horizontal asymptote. Okay, and I'm going to find the x-intercept. To find the x-intercept, I'm going to put 0 in for the numerator. It might be easier to use this unfactored one. If I put 0 into the numerator, I'm going to get 0 squared minus 1, which is negative 1. So the x-intercept is negative 1, 0. The y-intercept is where I'm going to put 0 in for all of the x's. So I'm going to put it here and there. So 0 minus 1 and 0 minus 4, I get negative 1/4, which is positive 1/4. I'm going to go and plot these 2 points. This is my actual origin right there. I didn't move it. I just have asymptotes everywhere. So there's that. And then there's that. Okay, so if I look at my dotted lines, I have 3 sections on top and 3 sections on the bottom. If I look at the middle here, this time looks like it's going to be a parabola because the 2 points are together in this section. So therefore, however, I guess it could have been a snake. Let's look at the last one for a second. The reason this one wasn't a parabola, yeah, I guess I should have checked. I was getting ahead of myself. Okay, I need to make a table. I'm not going to assume this is just a parabola, so let me erase that. It could still be a snake. So I'm going to pick positive 1 and see what we get. I'm going to put 1 in for these 2 equations. So 1 squared minus 1 is 0. That's going to give me negative 3, so that's going to give me 0. So yeah, it's right here anyway. Okay, looks like the middle, after all, was a parabola, upside down parabola. Since the middle was a parabola, the ends are going to be a volcano, but everything has to be symmetric. So since the parabola is upside down, the volcano has to be right side up, because I want some things up here and some things down here. Volcano is going to be on the ends. So overall, that's what our graph looks like. And again, we need lots of practice on this. I don't expect you to get it after me doing just these examples. Okay, last one. So first I want to factor. I'm going to take out a 2 and an x. It's going to give me x squared minus 9. I can actually factor that more. I got a difference of perfect squares. Okay, and then this is a difference of perfect squares. Okay, so looking at my factored equation, I'm going to find the points of discontinuity. So I look at the denominator here. I'm going to have a negative 3 and a positive 3. Okay, after that I'm going to cancel. They actually both cancel. That means they're both holes in the graph. Since they're both holes in the graph, I'm going to have ordered pairs. And then also, since something canceled, I want to write my new equation. Looks like I just have 2x. This is my new equation. So I'm going to put negative 3 in for x and positive 3 in for x. Negative 6 and positive 6. Okay. If I don't have any vertical asymptotes, I'm not going to have any horizontal asymptotes. So all I have to do now is see what I got so far. I'm going to plot these 2 points. There's a hole there. There's a hole there. Okay, I'm going to find my x-intercept now. That's where I set my numerator equal to 0. Well, I don't have a fraction, so just 2x is going to be what I'm going to set equal to 0, which means if I set my numerator equal to 0 and divide over the 2, the x-intercept is 0. So 0, 0. The y-intercept, that's where I'm going to put a 0 in for x. So if I put a 0 in for x, 2 times 0 is 0. If the x-intercept is 0, 0, so is the y-intercept. Okay, since I do not have any vertical asymptotes, my overall graph is going to be a line. So I'm just going to connect these 3 points, and I now have a line. All right, not sure if you really understood any of that, but there it is.